Hi, now let's go into multiple linear regression and make some more progress. Here I create this markdown with title multiple linear regression. Here the overall goal is to add more explanatory variables to right hand side of the equation and explain more variation in price. This more variation in price will be represented by r squared in the end. What do we mean by adding more explanatory variables? So we are going to take the stars of the hotels, also the rating. I think it was rating, maybe reviews or maybe rating. Yeah, let's write rating. We are going to add them. We already have the distance, right, as our single explanatory variable, and these will be fitted to a model to explain the variation in our price and learn more about the hotels. Here another important thing, okay, we say stars, but we are going to use the stars as binary variables or dummy variables, if you will. Let's formulate it here quickly. Stars as dummy or binary variable, and we are going to use those stars where they are greater than or equal to 3 stars and smaller than or equal to 4. So in the study we will only consider those hotels having 3, 3.5 and 4 stars. For study purposes, basically, I just want to create this filtered limited number of groups, okay? And more about that in a few minutes. We will do that. And let's try to write some code. We have our original data frame, not the original, but the intermediary, let's say, the df number 2, okay? This is df number 2. I'm going to create a new one called df number 3 using df number 2. But I need only a few columns there. I need the distance, price, and predictions. So distance, price, and predictions. These predictions are from the simple linear regression with one variable, okay? That's why I want to have a more representative name. I will use the rename function here. Rename function takes columns. It's a very useful dictionary, what I am passing here, where the keys are the old names and the values are the new names. So in this case, this is spread simple, okay? It can be a good practice to use these parentheses and have it look like a simple pipe. It's a good habit in my opinion. The earlier you develop this habit, the better in my opinion, because later on you will have complicated pipes and complicated Pandas code, and it will help you, and it will help your colleagues as well. So df3, let's quickly check how it looks like. Only 2 rows, please. See, now this is spread simple. However, I need stars and rating also. This stars and rating were from the first data frame, this one. So I'm gonna bring the stars and rating, this one, from this data frame into the df number 3, which I will use for multiple linear regression. Now, currently what we are doing is data cleaning and transformation for data preparation for model fitting, okay? So in data frame number 3, I need all the rows and a new column called stars. and this will be equal to df, the original one, all the rows, and the column called stars. Let's run this and see how it looks. df3 hat here. See, the stars came here. Similarly, let's copy paste this quickly for the other one, for the rating. It was rating, right? Yes, rating. Just change this to rating. The same logic applies. We are bringing the rating from the first data frame into the new one. When you run this and check with this, see, rating is here. Okay. However, here is the trick. The stars should be binary variable, and also stars should be 3 star, 3.5 star, and 4 star only. Which one to code first? Let's first filter. It's always a good idea to filter first. It will be important for the large data sets and big data applications, hopefully in the future. So we must be careful about where we apply the filter. Anyway, it's a distraction at the moment. However, I want to write my condition, because for the time being, if we check the stars and what values it take with value counts, we have 1, 2, and we have all sorts of stars, right? We don't want this. We just want condition 0. Let's start writing a Boolean mask. So in the F3, I have my stars column, and I want it to be greater than or equal to 3. Similarly, I need another condition. Let's call this the condition number 1. And again, stars. This time is going to be smaller than or equal to 4. When we pass these conditions to our data frame, condition 0 and condition 1, and check the resulting error, series object is not callable. Well, what? Okay, yeah, I'm doing a very stupid mistake here. Your df3 stars greater than or equal to 3, okay, is not callable. Okay, in df3 do I have, okay, let's just check what this df3 is. It's always a good idea to check what this is. Okay, and this should be greater than or equal to 3, right? This should be giving my Booleans. And this, wow, do you see that? It's unbelievable. This was really one of the most interesting things I have witnessed, on myself, of course. I simply didn't put the equal sign here. You know, if you don't have this equal sign, you don't have your variable. Now df3, now let's actually run the same value counts here. If you run this, you will see you have only these hotels over here. Great. Now we have this filter, and our data frame again looks like this. We mentioned that these should be dummy variables. How to get dummies? Okay, the get dummies function from Pandas to the rescue. That's why I love Pandas. They really have a lot of very convenient and straightforward functions like this, which were not as simple in the past. If you want to get dummies from a variable, you simply pass it to the inside. So this, in this case, our data frame is data frame number 3. Just select your column, which is stars, and observe the result. Right now this is just the result. We didn't do anything with this. What we want is to attach this to our data frame number 3. Attaching them is we can also call it concatenating, right? So we are going to concatenate it using another nice function from Pandas, which is pd concat. This concatenation function is quite popular and useful. Whenever I need it, I just read documentation, because it can get confusing sometimes. You need to be careful about how you want the concatenation. Do you want the columns side by side? Sometimes you may be unioning several data frames, just like a union all function in SQL. So first, have a clear picture about what you want in your mind. Currently, what I want is to attach this to the right hand side of df number 3. That looks like this. So I need these columns over here on the right. That's why I'm going to use an axis one. Here we need to pass our data frames first that we want to concatenate. So the first one is df number 3, and the second one is this one. This is a data frame as well. And if you hit Shift Tab, you will see the documentation, a summary of the documentation, which is quite useful. Here it says the axes. So this axis 0 is for concatenating like a union like a union function in SQL, or let's say you have a data frame and you want to attach the next data frame underneath. Then you would need an axis 0. So it's a concatenation by row logic. In here, what we are doing is axis equals to 1, because we want a concatenation with column logic to the columns. Okay, that's why the axis is 1. If you run and get your error message, maybe, yeah, here we need to pass our data frames, I believe, to a list. That's what I saw in the documentation, I think. Yeah. So you pass your data frames into a list like this as a parameter to this function, and then it creates what you need. Let's call this again df3. We are overwriting df3 at the moment with this concatenation. Okay, let's run this and then check the head actually. Cool, we are getting closer to prepping the data actually, but maybe I need to be more careful about the names of these columns, because I will need to run some functions. So these df3 columns, of course, not df column. The names of dummy variables, they are in float format, not string. I just want to quickly change them to my liking, to a string format. There are other ways of doing this, of course, again, but I will quickly change them to strings like this. So I will call this 3 star, and then I will call this 3.5 star, and the last one 4 star. Oops, I hit enter by mistake. 4 star. I'm going to rename the columns this way, okay? If you now run the head, you will see they were changed to a string format actually. And let's see what we have here. Okay, we have the 3 star, 3.5 star, and 4 star. And let's talk a little about how we would fit them to a linear regression, because we will need to drop this 3 star hotel column. Why? Because we are going to use dummy variables, and when the 3.5 star is 0 and 4 star hotels are also 0, the equation will automatically give result for 3 stars. So we don't need to indicate this separately. When these are 0, these two are 0, this is all automatically 1. So we just drop that. Another way of saying that, so let's say that this is our multiple linear regression formula. This is our intercept, right? This is our distance. Beta naught here stands for its slope, right? And then we have our dummy binary variable for 3.5 star hotels, and then another dummy variable for 4 star hotels, right? If this is 0, the binary variable, then this part of the equation becomes 0. And if 4 star hotels are also 0, then these are multiplications, right? This part also becomes 0. And then this part of the equation naturally stands for 3 star hotels when these are 0. This is how we set up dummy variables, okay? Now, if we have 3 dummy variables, actually we need 2 dummy variables to represent 3 categories, and -1. Let's do that. Let's drop that. df3 drop. These functions are almost like talking to the computer. Quite straightforward. Axis is again 1 because we are dropping column, right? When we think about columns, the axis is 1. When we think about rows, then the axis would be 0. And I want this to happen in place. I don't want to assign it to a variable. I just want it to happen automatically in df number 3. That's why in place is true here. I want to drop that. I also want to drop this stars variable because I don't need it anymore, right? Because I created my dummy variables. Let's write it here, stars. And we need to pass, if we are dropping multiple columns, we need to pass it to a list like this one. Okay, let's check the outcome. Oops, I didn't like that. It's probably an error message. We are not drop. Oh, I wrote drop here. I am dropping stars and 3 star. This was good. And 3 star. Okay. Let's see if this is running. Okay, I like that. Let's see how this looks. Now we have, yes, 3.5 star, 4 star. I have my rating, price, distance. Cool. Let's check our descriptive statistics before we do something. It's generally a good idea to check the ballpark numbers before you do something. Let's see what we have here. We have the distance. The minimum distance is 0. I want to deal with this issue first. So these distances are the distance from the cathedral in the city center, and I don't think there are hotels built on top of the cathedral. There's a small distance, right, all the time. I want to account for it. I don't want to have 0. So if the distance is smaller than 0.05 kilometers or miles, I don't know, then I will equalize it to 0.05, but not 0. Let's see what we can do that. Again, we will use the Boolean masking here, right? So df3 lock, we can use the df3 and select the distance, and this distance should be smaller than 0.05. So these are the ones smaller than 0.05, okay. And again, I want to overwrite the distance, but only for those smaller than this number, okay. And I want them to be 0.05. Let's actually see what's happening after we run this. Again, if we run the describe function, this time you will see the minimum distance is 0.05, which looks much better. The maximum number was 13 already. We learned that in the previous practices. Let's check our price second. So there are some extreme values in the prices, and it is better to call them influential values actually. Some people prefer using outlier, but I don't like that name for these kind of situations because these hotels are in the data set, and it can really happen. Some hotels may charge these values, so they are not actually very out, let's say. That's why they influence the outcome of regression, and this is the reason I prefer using influential variables. If you read the book that I mentioned at the beginning in the first video, you will learn more about these kind of influential variables and how to handle them. Here, just for the sake of the practice, I just want to apply a simple filter to the price. I want to get the prices smaller than 600 in this regression study. So how we do that is df, again, we can, should I write a condition separately? Maybe not. Let's just go for it. df3. So if this price is smaller than 600, so I just want these hotels, and they are 339, and here 340. Actually, by doing that, we will be dropping only one hotel. Okay, let's do that. Now I am reassigning df number 3. This new data frame will have only those hotels where we have price less than 600. And if we run the describe again, this time the price changes from 50 to 511. Okay. This, we will not talk about this simple linear regression outcome yet. We have our rating changes from 1 to 5, right? And 2 dummy variables, 3.5 star and 4 star. Cool. What else? We did the concatenation, created the dummies, right? And then we applied several filters. Our data is quite ready, actually. Let's check our documentation here. Now we are wondering how to fit the model and interpret the coefficients and talk about our target variable using the new model and how it is different from the original one, how the R-squared has changed, etc. Let's give a 5-minute break and then we jump right into the fit function, get the model, get the predictions, and talk about the differences between the models and their coefficient outcomes. Okay, see you there.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.